Pre-statistics. Exponential functions, part 3. Lesson objective. Use 2 points to find an equation of an exponential function. We'll begin with an example. Example 10. Find an approximate equation y equals a times b to the x power of a exponential curve that contains the points 0, 3 and 4, 70. Round the value of b to 2 decimal places. Solution? Well, first we're given the y-intercept. 0, 3 means that the y-intercept is 3 because it is the value of y when x is 0. That means that our value of a is 3. So now we have y equals 3 times b to the x power. All we need to do now is find the value of b, the base. So we're going to use this point here, 4, 70. When x is 4, y is 70. So substituting those values in for x and y, we can solve for b. So we have an equation that only has one variable, b. So solving for b, we need to get rid of the 3 and we need to get rid of the power of 4. Dividing by 3 first, we get 4b equals 70 divided by 3. Take the fourth root of 70 divided by 3 and add our plus or minus. We have the solution b equals plus or minus 2.20. Now, because exponential functions, the base is always positive, we only need to write down the positive solution, 2.20. An exponential function, the base cannot be negative. So we have our equation, y equals 3 times 2.20 raised to the x power. So this graph contains a 0, 3. It doesn't exactly go through 4, 70, but it's close. And the reason why it doesn't is because we are rounding b to 2 decimal places. Lesson objective. Property. If a equals b and c equals d, then the equation a divided by c equals b divided by d. In words, the quotient of the left sides of two equations is equal to the quotient of the right sides. Now let's look at an illustration. Let's let a be equal to 5 and c be equal to -4. Then b also equals 5 because a and b are equal, and d equals -4 because c and d are equal. So if we plug these values in for this equation, we have 5 divided by -4 equals 5 divided by -4. So it works. The left-hand side equals the right-hand side. So you may ask, why do we need this? Well, let's look at an example and we'll see. Example 11. Find the approximate equation y equals a times b to the x power of the exponential curve that contains 2, 5 and 5, 63. Round the values of a and b to 2 decimal places. Unlike example 10, where we're given the y-intercept, we're given 2 points and we don't know what the y-intercept is. We have to find it. So solution, since both points must satisfy the equation, we have 2 different equations. We need 2 equations because we have 2 unknowns. We don't know a and we don't know b. So if we substitute 2 for x, that will be equal to y, and for the other point, when x is 5, y is 63. Now this will be easier if we put the largest y value first and then the smallest. Now why do we do this? It's because now we are going to apply that property where we divide these 2 equations. So this system is equal to this. 63 divided by 5 is equal to ab to the 5th power divided by ab squared. Now next, the a's will cancel, and then we have b to the 5th divided by b squared, and these bases are the same, so that means we subtract the exponents. And we have b to the 3rd equals 63 divided by 5. Now taking the cube root of 63 over 5, we have b is approximately equal to 2.33. So we found our first variable, b. But now we have to find a. So we put b in, we pick a point, it doesn't matter which point. I'm going to use 2, 5. 2 goes in for the x, we have our value of b, and y is 5. Next, we want to square. So next, we want to solve for a, so this value is multiplying the a, so we divide, and we have a is equal to 5 divided by 2.33 squared. Evaluating this, we have a is approximately equal to 0.92. So our equation is y equals 0.92 times 2.33 to the x power. They should come close to these points. So to verify this using the graphing calculator, we put the equation in y1, we hit graph, and then we can use our trace feature for the 2 points. Summary: we can find an equation of an exponential function using the base multiplier property or by using 2 points. Both methods give the same result. So now we know how to find the equation of an exponential function using 2 points algebraically. We can also find the equation of the exponential by using the regression command on the graphing calculator. To do this, you go to Stat, enter for edit, type in your x coordinates and y1, so that will be 2, and for the second point 5, then input your y coordinates. So the first point was 5, the second point y is 63. Next, go to Stat, right arrow to calculate, and scroll down to 0, which is exponential regression. Hit enter. List 1 is our x, list 2 is our y. And if you have an 84, we can use this store regression equation. We'll put this in y1. So go to vars, short for variable, right arrow to y vars. Number 1 is function, and we want to use number 1 for y1. So this will store the regression equation in y1. Finally, we hit calculate and enter. And here we see the value of a is about 0.92, and here we see b, the base, is 2.33 rounded off to 2 decimal places. Looking at the scatter plot, I make sure it's on, second, and stat plot, I hit enter. Currently mine is off, so I hit enter to turn it on. Double check for the type, we're doing a scatter plot. My X list is list 1, my Y list is list 2, that's correct. So finally we hit, just like with linear regression and quadratic regression, we hit zoom, and then number 9 for zoom stat. Here we can see the 2 points, and our equation is going through those 2 points. If we hit the y equals button, we can see the equation is pasted in, and the calculator did not round. So this is all the value of a, and then that's being multiplied by the value of b. And then it's being raised to the x power. We can also verify it using our table feature, second, and graph, which is table. We can see when x is 2,
y is 5, and of course when x is 5, y is 63. So it is a lot faster to use the regression command for exponential functions.
Thanks for watching.